Welcome back to the Student Hub Live Refreshers Orientation event. Well, we've had some fantastic people from the Open University tell you all sorts of things like what you should eat when you're studying, how to spot fake news. We've talked about student support teams and we've talked about creative uses with stationaries and had a look at assessment. We've covered a lot, but what we really need now is some bangs and pops. So I'm joined by Rob Janes and Mike Batham to do some live science. So Mike, what's your role here at the Open University?
Yes, I'm the lab manager for the Open Science on Campus laboratories, and we make videos, we carry out labcasts, and we also do lab schools, which is a bit like a residential school but on a shorter time frame, so 2 to 3 days, and we do face-to-face teaching of undergraduate students. Now,
you've brought some things in here today to show us, but your lab is a lot more technical than this sort of thing normally,
yes,
isn't it?
Yeah. Well, one of the things that I do is I'm also working on remote experiments. So with remote experiments, the idea is that we create an experiment and the students actually perform that experiment for the comfort of their own home.
What sort of things would they do?
So we've already done one with infrared spectroscopy, and so the students make 2 compounds in the lab school and then they analyse them by infrared spectroscopy from the comfort of their own home. And the one that we're going to launch in 2 weeks' time is a titration, where they're looking at an acid and reacting it with a base and monitoring it with a pH electrode.
Wow, that sounds fantastic. When you say comfort of their own home, I mean, that sounds good. I'm just hoping this isn't too uncomfortable and whether I should be having looked at the emergency exits.
It's all been risk assessed and it's perfectly safe.
Excellent. And Rob, you're going to tell us about some of the level 3 labcasts.
Yeah, we've got demonstrations that we do in all our labcasts here, but this is actually the first one I'm going to show you is actually from our level 3 chemistry module, and one of the key focal points of that module is actually metals and different sorts of metals. So what we have here is solutions of nickel, not nickel metal, but what we call nickel ions, and these are these green solutions. And basically the reason it's green is because you have a nickel ion and water molecules are surrounding the nickel, but we can replace those water molecules with a different molecule and actually fine-tune the colour. So this is something called ethylene diamine, and you'll notice that if I just pour it into, I'm not very good left-handed actually, into the flask, we get a nice colour. This is the same colour, or the origin of the colour is much the same as you see in gemstones, stained glass windows, that sort of thing. I'm just stepping in front of you now, Karen. If I add some more ethylene diamine, this is a slightly larger volume. We can actually tweak the colour a little bit further, so we've got a sort of green with no ethylene diamine, blue, deep blue, and if we add a bit more ethylene diamine, we can even go a stage further, hopefully, and we get a deep purple colour. So tweaking the colour with a little bit of chemistry.
Wow, excellent.
OK, I think we're going to move these away from you for the time being.
HJ, have we got any science students out there in the chat who may be engaging with any of these labcasts? Or even, I mean, this is reminding me of our conversation about highlighters. And I know that if you highlight like the green over the yellow and things, you can get all sorts of colours depending on whether you go too much into them.
Well, we'll have to find out. I know we had some science students earlier and people were telling me we're having a conversation, a little conversation about Oreos on the side, which I'm not sure if there's a scientific test to find out which one's the best. But when it comes to highlighters, I think we're experts and we don't need too much practice with those. But,
I've been making a note of my favourite biscuits in my my handy chocolate notebook, actually. So we'll put.
What's on the top one? Do we have one?
Hobnob still.
Hobnob still.
Yeah.
But that's fighting through. But yeah, we'll have to find out here. But oh, we're looking at highlighter chemistry experiments as well. We had a thing about putting things in microwaves at one point.
We're not allowed to talk about that.
No, we won't do that again.
All sorts of bother about
We can't help you with that one.
Yeah. OK, so these labcasts that you've been doing, Rob, so this is something that students might be able to watch as part of their studies.
I mean, the labcasts are all tied into the actual module, so they fit in with the teaching within the module.
And it's great because often people think, oh, studying science, you know, it's so practical, but this offers a way of doing things, both in terms of watching some of the experiments and also, like you say, Mike, about doing some of them.
Yeah, actually carrying them out at home.
Yeah. And it's not just the home thing, because actually a lot of students generate a lot of data, so it's quite exciting as well to be able to get a massive data set you can then analyse.
Yes, yeah. So when they finish the experiment, they can download the data from it, and it comes down in Excel format, so it can be picked up by Excel and other graph plotting packages that we can use.
Yeah.
So it's very good, and we can build up a bank of data, as you say, and see how it varies over the next few years. It's going to be very interesting.
Excellent. OK, right, we've got another... I'm going to stand behind you two gentlemen, because... Not that I don't trust anything going on, it's just...
Okay, so...
you are the front of show.
What we're going to do now is move back to our level 1 labcast, and that labcast is all about oxygen and the properties of oxygen. And we always start out by making some oxygen, and we're going to do it here in two completely different ways, using some chemistry and, if you like, using some physics. This chemical here is something called hydrogen peroxide. It has the formula H2O2. And you probably know that water is H2O. It's sort of very famous. And being very small, chemists like to build models of atoms and molecules. And there's water with an oxygen in the middle, two hydrogens. So it's H2O. And here we have hydrogen peroxide, slightly weird shape. This time it's got two oxygens, two hydrogens. So it's H2O2. So it's like water with some extra oxygen. And we can actually release that oxygen using a bit of chemistry. There's our hydrogen peroxide. It's not doing a great deal at the moment.
Chemistry and fairy liquid, eh?
Well, yeah, so you're probably thinking, what are we going to make?
Detergent available.
Yes, indeed.
In fact, we refill it with a cheaper value.
So this is a very slow chemical reaction. We speed it up using a catalyst, and there's our catalyst that goes in. I'm trying to do this on
Wow. Oh, my goodness.
So if any of you do an S111, you'll see my colleague Nick Chatterton do this outside on a much larger scale using a liquid catalyst, which actually, this isn't doing too badly about going everywhere.
Wow.
So what we can actually do, try to do...
steam as well.
Yeah, there's loads of heat, and that's important for something we're going to show you later on, actually, heat produced in chemical reactions. You probably noticed when I put this burning splint in, I don't know if you're picking this up on camera, the burning is a lot more vigorous. I can even go a stage further, blow it out, and it's relit. Can you see it relighting in there?
Oh, yeah.
And that's one of the key properties of oxygen. Things like to burn in it, or we say oxygen supports combustion. So I'm glad that's died down. I was getting a bit worried.
Yeah, you never know how much is
I don't want to
too
make
much.
a mess of things.
Yeah. Wow.
And what I think we're going to show you now, or I think Mike's going to do, or we'll both sort of do between us, this is a little bit more elaborate, is actually to make some oxygen using a bit of physics.
OK.
OK, so what we have in the blue dewar is liquid nitrogen.
Right.
So it's nitrogen that's been cooled down to minus 196 degrees Celsius. And we're going to pour it into the cola can. And
Is that a good idea?
if I'm careful, again, there will be a little bit of steam.
We only want a little bit, don't we, for this? There we go.
Yeah. OK. Now, it's cooled the can down, and what you see is liquid oxygen, which has a boiling point of minus 183 Celsius, and that's condensed at the bottom of the can. And if you look at the close-up, you can see droplets of liquid oxygen have fallen onto the watch glass.
So let's prove it's liquid
and let's
oxygen.
prove it's liquid oxygen.
Remember the glowing splint test? With a little bit of luck, we can actually, I don't know if you're picking that up, you can see it relighting the glowing splint.
Wow.
So that actually is
liquid oxygen.
Produced by a physical method.
Gosh.
Okay,
No
so-
wonder you don't want people doing this sort of thing at home. I think it's best that you do it for them in the
I always worry
isn't it?
about these people who make ice creams with liquid nitrogen. There's a high probability you might start to make liquid oxygen as well, but
Oh,
I don't
really?
know.
Oh, I
Who
don't-
knows?
They don't say that
Who
on
knows?
MasterChef, do they?
And then we talk about combustion in the lab gas. You know, we've made some oxygen and we do a few combustion
safety
reactions.
measures are increasing.
Safety
Yeah.
is breathed out. Yep.
Yeah, so what I need is, this is something called calcium carbide. It's a chemical that releases a gas called acetylene if you add water to it. And what, sorry, I'll do it, don't worry, I've got it in mind. Yeah, I'm okay, we'll be all right with this
Are
one.
you sure we're OK doing this? I mean, I noticed that this is here for the cameraman, but what about me?
I'm not sure, no. There's always, if I get the right stuff. And no, I don't want to be putting alcohol in it, Mate. Okay,
It's
so...
important to clearly label, isn't
And
it?
acetylene, actually, you can see straight away, starts to burn straight away. It's quite flammable. It's one of those fires. Actually, it's gone out. But it's actually quite difficult to put out because you produce more and more acetylene and it burns. Anyway, thankfully for us, it's put itself out.
Yeah, can you pass over the lamp?
Oh, yeah, sorry, yeah. So that reaction actually has a practical application.
Yeah.
Or-
So in the days before batteries and generators, the early cars and motorcycles used to have what's called a carbide lamp. And what you do is you put water in this top reservoir, and it has a little needle valve which allows the water to drip, drip. And the calcium carbide is put in the base here. And then the acetylene gas goes through this tube into a little burner. So it's like a little Bunsen burner.
Oh, yeah.
And you light the burner and you get a very intense flame, which used, in this one, this was used on a motorbike and dates from 1912. And I managed to get it on a well-known auction site, which I can't mention, for a mere £25.
Wow.
However, it doesn't work as good as it did when it was in its youth, one has to say.
Right.
But it's a good thing to show. And also, miners used to use these for their lamps and cavers as well. And cavers still use it as an emergency, so if their batteries run out, they've got a backup lamp. So, that's good.
So we have another combustion reaction to show you, Karen. This is a little bit
Excellent,
more...
good.
bit
Yep.
more. We've scaled this down to what we normally do because
Yes.
obviously we're in quite a confined
Just
space.
move it back
It's
slightly.
a mixture of a reactive metal called magnesium and a chemical called silver nitrate. Now, magnesium basically kicks the silver out of the silver nitrate, produces a lot of heat. So much heat is produced to actually ignite the magnesium. But the way these are two solids, so we need to get them mixed. So we do it by adding a drop of water, and we probably need to step back because Mike's going to use a water
yeah.
pistol to do
Okay.
it. So.
A water pistol.
Yeah, I'm going to show my James Bond skills and shoot it with the water pistol.
Oh, wow.
There we go.
Sorry, John.
So you can see the reaction is so hot, it's actually melted the aluminium foil, you can see. There's a little bit of smoke coming out of it.
I knew this clipboard would come in handy.
I think we'll get rid of that one,
We'll
shall we,
just put it
completely?
in there to...
So you're probably getting the idea now, Karen, that all these chemical reactions are producing loads of heat and energy.
Yeah, I'm in the wrong department. I
But,
want to come and work with you guys.
But that isn't, it's
Yeah,
not...
what we're trying to do is to show that science is fun. You know, it's not all serious, and it can be entertaining as well as informative.
Absolutely.
As well,
Who
yeah.
wants to sign up for a chemistry level 1 module with me?
Right,
There we
Mike,
go.
can you...
Oh, yes.
Can I have the next
Yep.
reaction, please? So this is something completely different.
Now for something completely different.
So we have to sort of set it up here. It's we probably don't need the... No.
Well, I know HJ wants to feed us some chatting, and we've got a bit of time.
Yeah.
So why don't we take a quick
take
trip to
some?
the hot desk?
Yes.
Fran does say that that last one's a good way to spark up a conversation.
Yeah, so very good.
But we've also got some people that are very glad that it's done through the Open Science Lab. So someone said, my flat's rented, so it's best not that I try some of these.
Please don't try this at home.
And yeah, we are afraid of blowing some stuff up. But Jane says, wow, that looks fascinating, which it really is, coming from a non-science background. I love it when you guys come along. And Amanda says, loving these amazing experiments as well. So what I've done is I've posted the link to the Open Science Lab in the chat as well, so we can have a look at the experiments
so
on there
people
later.
can have a go from the Open Science website at some experiments from the comfort of their own home. For example, they can do the flame tests. This is one that we filmed quite a few years ago, but it's still relevant today.
We've also had that in S111 and S112. There's a whole load of kitchen table experiments as part of the module, so students actually get the chance to actually carry out experiments themselves.
And for people who are not studying science, is there much on Open Learn that they could engage with?
Loads of courses, actually, yeah, including home experiments as a module
There's
short
a
course
module
on that,
home
yeah,
experiments,
yeah.
and a module on water quality,
yeah.
which we filmed a few years ago.
And great for doing with your kids if they've got these homework assignments as well.
Yeah.
So OpenLearn, for those of you who don't know, is a range of free content that's available from the Open University, often from modules that we've got going on. So it's a great thing to look out for. And in particular, if you're getting ready for study and have a couple of weeks spare, you might like to check out what's available for you. OK, this looks interesting.
OK, so I think we've probably given you the impression that all chemical reactions produce heat, but...
Yes, and smoke.
And smoke, but that isn't the case. This is something, as I said a moment ago, completely different. Two chemicals. This is something called ammonium thiocyanate. And what I'm going to do, you'll notice it's a solid. I'm going to mix it with a chemical called barium hydroxide. Now, Mike, I need a stirrer, actually, over there. So let's mix these two together. But before I do that, I've got to prove to you that reaction is not producing heat, and in fact it's doing the opposite, it's taking heat in. So what I'm going to do is, on this wooden block, just put a few drops of water. Hopefully it'll all become clear in a moment or two.
OK.
Spread it around. OK.
Yeah.
I've got a better stirrer for
Ah,
you.
fantastic, yeah.
That's a more
That's
technical
much
stirrer than one from the canteen.
That's right.
OK, so the second chemical we had, now there's another indicator that this reaction is producing or taking in heat, and a reaction's taking place, is because something we can't convey to the people watching online is the awful smell of ammonia that is now being produced. It's not. We've scaled things down from our usual level, but...
OK, so ammonia is an alkaline gas. So one way we can test it is with an indicator.
Does anyone have a peg for my nose? It's
You can see it's turned from green to blue, showing that it is indeed an alkaline gas.
Yeah.
And sorry about the smell.
No,
but,
well, it's rather like one of your colleagues came along to the Open Day and they gave me these fantastic postcards about, I can't remember, which planet was it? Anyway, it smelt of urine, and I've got these postcards and I posted them out to all the students, and it stank. It was comma 67p. It was really, really bad.
Yes.
Yeah. OK, so we've not proved to you that the reaction's getting colder yet.
No.
So remember the water that we...
Oh, my
Can you see now it's actually frozen into ice?
It has.
So the heat of the reaction has dropped so much that we've actually frozen the water.
And is that ice around the edges as well?
A little bit, yeah, a little
Wow.
bit. So that's what we call an endothermic reaction. So it dispels the myth that all reactions produce heat.
So
Fantastic.
heat is taken in.
OK.
Amazing.
I think the smell's died down now, actually. It's
Yeah.
not too bad. We thought we'd
OK.
warn you, though.
Right, all right. So have you got a spectacular thing to finish on?
Oh,
Shall
yes.
I,
We've got 3 liquids.
Yep. So I've got 3 liquids here.
Right.
So the first one, let's get the right one. So the first one is alcohol. And in fact, we're using propantuol, which is often called rubbing alcohol and used in hospitals before you have an injection. OK. You can use ordinary ethanol, but what we found was you get...
Is that the right one?
A better...
You've got the right one there.
A better flame.
Yeah,
Yep.
sorry.
So move that out of the way. And then...
to light it.
Yeah.
Oh, wow.
So you can see it burns really strongly.
Yeah.
And the paper is in fact a polymer, and it's a polysaccharide, so it's made of sugar molecules, so they're rich in carbon. And you can see it's turned black and then grey as it's burned in oxygen to form carbon dioxide. It also produces nitrogen oxides, so any combustion reaction does that. OK, so like all scientists, we have a control experiment, and for our control, we've got our paper and some water. OK, and immerse it in the water like before, and then when we try and light it, well, guess what? It doesn't ignite, and it shows that water suppresses combustion and is used in fire extinguishers, and the fire brigade have it in their fire engines. So,
Not very spectacular, if I do say so myself.
OK, so what we have here is a mix of water and alcohol. And I've got a theory that if we immerse the paper in that water, then we can light it and the alcohol burns on the outside and the water stops the paper from burning. Now, are you brave? Do you think you could lend us a £20 note we could do that with?
HJ, do you think that's a good idea?
Well, they are the experts. I know. Jane was telling us about some accidents that they've had in Holland because they use carbide to produce combustion in a milk churn, and it blows the lid off in her experience.
Yes, we wouldn't recommend doing it on that scale.
Not that one.
On the big side.
So is this a bit safer than that?
This is a little bit safer.
Okay.
Yes, yeah.
We do it in a treacle tin in the labcast.
Yeah, we have
but
done
it's
it in a
not quite the milk churn
and
scale.
blown
but-
the lid off. But we didn't want to do any damage to the cameras or the lights. So are you going to be brave? And
Yeah, I've got one in my...
I just wonder what else is coming out of there.
in your chocolate notebook.
Sorry, yeah, there.
Okay. So
My essential
there we have
stationery
yours.
things.
Yes.
That's my biscuit thumb.
We have to use 20s these days because with all these plastic 10s and 5s around, it's ruined our act, actually, hasn't it?
Oh, has it?
Yes,
It's increased the jeopardy. But,
yes, it's increased jeopardy, but lowered the value.
okay.
So, yeah, now if we just take it out, careful.
Yeah. I'll just move it out the way.
Okay, move it out the way.
So we don't... OK.
So, look carefully, down the bottom, down bottom.
money to burn, I wonder?
Oh, no. Oh, it's not burning.
Yeah, it burns very, very quickly. And you can feel it's quite damp.
Yeah.
So the water has prevented the £20 note from igniting and the alcohol burned on the outside.
Oh, wow.
Thus proving our theory correct.
It's still good to buy
Okay.
biscuits with then, I assume.
Yes.
Wow, that's fantastic. Excellent. Well, thank you both for demonstrating all of this. What do you guys think at home? Who's signed up for a science module and who's interested in studying science at the Open University? HJ, what's everyone talking about?
We're just a bit in awe, and I think you're very brave for giving over £20 notes, but all in the name of science, isn't it?
That's right. The things we do for science.
But we're looking at the open learning courses as well. So I'm quite interested in the water quality one, especially given where I live, because I live by a very, very big factory, and it does worry me. So it's interesting to see like the practical applications as well of what we're learning about in our modules and the experiments as well.
Yes, yeah.
Any advice, gentlemen, before we go, about students studying science with us? Because a lot of the science modules are online, and we've been talking about various uses of stationery, various things to read with, and also in our boot camp last week, we were talking about making the most of, PDF readers, annotated PDFs, and really using your online material to the best advantage. Studying science involves a lot of different things. I mean, people will have audio-visual material, they might be watching chemical demonstrations, they might be, seeing a range of different formats. What advice would you give to new students out there about trying to amalgamate some of this content?
It's quite a challenge actually studying online, and as you say, Karen, it's enabling us to bring together so many different forms of media, a whole variety, a blended approach to the way we teach. Advice, it's difficult really to give any particular advice.
Perseverance, you've got to persevere, and please attend the tutorials, and watch the labcasts. Even if you can't make it on the day, it's recorded, so you have a chance to watch it again. And you might think about watching it again before your examination, just to refresh your memory.
Yeah, some good advice.
Yeah.
Excellent. Well, thank you both very much. Are there any questions anyone's got about studying science before we get ready for our quiz?
I think Ronald was saying about health and safety, but I suppose with the level 1 where we do it in the kitchen, we're not so worried about that. But
the experiments will have been risk assessed. I mean, we don't ignore
yes.
it.
I think some of us know that we sometimes give in to the temptation to maybe set things on fire that we shouldn't in the chat, it seems. But no, we've really enjoyed it, and everyone's having a look at the Open Science Lab and the webcasts up there as well. So yes. Thank you from everyone in the chat.
Okay.
Wonderful.
Thank you.
Well, thank you very much, Mike and Rob, for coming along today and giving us some chemistry. OK, so you've met some fantastic people here at the Open University who've told you about how to study, what they do, and shown you really why the Open University is such a vibrant, fabulous place. Well, next in store for you, we have our famous Wheel of Ologies quiz with Professor of Planetary Sciences Dave Rothery as quizmaster. You at home will play against our audience, teams from the Research and Academic Strategy Office. The quiz is loads and loads of fun, and we're going to play you a short video about social workers, and we'll join you in a few minutes for our quiz. See you soon.